Hey, and welcome back to the lab. Thank you for joining me for the first Mikey's Lab, or inaugural, I guess, Mikey's Lab mailbag. No need for lab coat today. Unfortunately, no experiments. A couple more videos coming up with those in the near future. A couple of my viewers have mentioned that they'd like to see the things that I get and to have me point out where I get them from. So, with COVID-19 being a thing, you'll have to excuse the fact that these have been taken out of their original shipping containers in order to ensure that I'm not bringing a virus into my house. So, let's just jump right into it. So the first thing we have is a few of these. I didn't know how much I would like these, so I only ordered 3 of them. And what these are, if we take a closer look, these are boost converters. So they take any reasonable voltage and boost it up to another reasonable voltage. So these are often used with lithium cells, single cell lithium cells, to move from the 3.7 to 4.2 voltage range to a 5 volt range for circuitry. I've been told that these have an Achilles heel in that they cannot be adjusted while power is applied to it, which would make sense given the IC that they have, but we'll do some tests, we'll find out. And we'll see if these work going forward. The circuit for these is very similar to a circuit I designed for one of the projects that will be coming up shortly in surface mount soldering tutorial. Yeah, so hopefully these work alright, and the circuit that I designed, which doesn't have the variable nature to it, it just has fixed resistors for setting the voltage coming out of these, will work quite well, right? But we'll have to dig into those later and see. Next we have, and for some reason I ordered a bunch of these, but only one showed up, right? We have a single cell Lipo Usbc charger. You just see what you can see here. Move to a slightly different camera. USB-C charger. So what you have your USB-C or 5.2 volts in. You have your battery out, right, which goes to the battery, and then you have the circuit out. This gives you some protections for the battery and will allow you to charge it with a standard USB-C type connector. This does not take advantage of the voltage negotiations of USB-C. These things are really dirt cheap and they're found everywhere, usually in conjunction with the step-up converter that I showed you, that I just showed you, to handle a single-cell lithium-ion battery and allow it to power some 5-volt electronics. So you've seen me use these before in the lab. Usually they were the micro USB version, not the USB-C version. But essentially there really is no difference. Next we have what I believe is a 9 degree of freedom accelerometer, which is again for a project that I'm currently planning, and I'm not really... Oh, this is the 10 degree of freedom one. Alright. Which is currently for a project that I'm working on. If the project is successful, there'll definitely be a video for it, but this is designed to track motion, and it is a very important part of what I'll be doing. These are, again, remarkably dirt cheap. It supports the input voltage of 3.3 to 5 volts, so whatever your microcontroller is, it should be able to work fine with it. Right, all in all, I think that this will do what I want it to do. Again, this was a couple of dollars off of Banggood. I ordered more than one. There's about 5 or 6 of them that showed up. I always like to order extra of parts like these because I never know when the next project I'm going to do that could possibly use one of these are. And as you can see by my shelves, I tend to hoard parts. Alright, so moving right along. I ordered these. There's 4 of them, but I'll only bring 2 out. A4988 stepper motors. Or not stepper motors, stepper motor drivers. This is for a project that I am working on to try to... Essentially, I want to build a really large cricket. I don't know why, I just have this desire to have a vinyl cutter. So I started ordering parts, the extruded aluminum, and a lot of other stuff that hasn't arrived yet. But these are two of the stepper motor drivers, which will be able to handle X and Y. These are an old generation style of stepper motor driver. They're not the trilinear or trinomic. The new stepper motor drivers that are silent. Right. This is probably if you have like a Creality 3D printer, or you have any type of the old Prussias. This is probably what's driving the NEMA 17 stepper motors in there. Where you can see you just have your IC, you have the standard pinout of a stepper motor driver, and you have an adjustable capacitor to change the reference voltage for the adapter, which directly affects the torque that the motor puts out. So these are kind of neat little devices. I believe these were about $4 or $5 a piece. Not that expensive when you compare them to the other ones that will be in this mailbag that are designed to go into a replacement for my 3D printer. But they'll definitely do the business for most X and Y plotting type arrangements that you want. Again, if my experimentation in creating a large-scale open-source cricket is successful, there'll be some videos here. Along the lines of the projects that I'm doing, I ordered a bunch of these, and about like 20 of them arrived. So I don't know if I ordered 20 or if that's just how many showed up. But these are 3.3 to 5 volt logic level shifters. They're just jelly bean components that are used all over the place. If you're using a 5 volt Arduino, if you're using a 5 volt microcontroller, and you want to reference a sensor that's 3.3 volts, sometimes trying to do that directly will damage the sensor. Sometimes it just can't handle that difference. So this board uses a bunch of transistors in order to convert the signal from 3.3 volts to 5 volts, and from 5 volts to 3.3 volts bidirectionally. It's a very handy little board, dirt cheap. Heavily recommend you have a bunch in your kit for when you need them. Alright, so that's the end of the little stuff. Next, we have massive rolls of Dupont cable. Anybody who's been watching my channel for a little bit knows that very recently, somehow, I managed to run out of hookup wire. I've said it before and I'll say it again. One of these years I'm going to clean up my lab. Won't be today. I have been using what's known as wire wrap wire, which is really thin wire that is really good for making modifications on a circuit board or doing a prototype PCB type thing, but is not really good for hooking up components external to each other. For example, hey, I found something I can show you. For example, this LED matrix. I have all of the wires of the matrix hooked into the ICs via this really, really thin wire wrap wire. Don't get me wrong, it works very well for what I want it to work for, right? And it has served the purpose, but this is not a good implementation of how to use this. So I ordered a bunch more Dupont cable. This I believe is 20 strand, and I don't know how long it is. But this type of cable tends to be the perfect size to go between ease of soldering, flexibility, and just color range and ease of use for going between two boards, going between a component in a board or a sensor in a board, where you don't need the critically thin nature of a wire wrap wire. I use these quite a bit. You've probably seen me do it many times on the experiments on the channel. So I bought some more, and hopefully that will last me a little while. Alright, now we're into the really interesting stuff. My Creality CR10 has served me incredibly well over the year or 2 or 3, I don't know, however long I've owned it. It has been an absolute staple in my lab and has been awesome. It has been running the standard Creality board, version 1.1 that came with it since the day I bought it. I have nothing but compliments for this machine. However, according to my wife, the sound of it printing is like a dentist drill to your brain. So that I took the cue that it was time to upgrade the 3D printer, move to something with silent stepper motor drivers, and I had the choice of going with the new Creality board with the silent stepper motor drivers, or stepping up to the 32-bit world and going with a big tree tech here. This is the SKR 1.4. Alright, so let's get a first look at this board. Inside, you get your proverbial rubber ducky. Never understood why the rubber ducky. Hey, it squeaks! How come nobody else has made this thing squeak? Alright. You get full-size USB cable that's mini, probably about 6 inches long. The big tree tech, where to find the official website, stuff like that. And then we have the board itself. Let's get the box out of my way. New PCB smell. Gotta love it. Oh, and it comes with an SD card. Alright, I did not know that. A whopping 128 meg. Wow, that'll be useful. Anyway. We have the 32-bit processor here. This is not the turbo version. I didn't see the necessity of the extra 20 megahertz. I really didn't. It has the spots for whatever stepper motor drivers you want to run. It has the ports on the outside for each individual stepper motor, including the dual Z-axis port. I only run a single Z-axis extruder, or a single Z-axis printer, so it doesn't really matter, but it is a neat touch. There'll be a video coming up showing me upgrading this. This and all the 3D printing related parts that you will see today, I got from 3D Printing Canada, which is a phenomenal company. They're located in Hamilton. I found them quite by accident when I ran out of filament, and I would normally order from Amazon, but with COVID, everything was going crazy and it was hard to get shipments anywhere. So I started looking for a Canadian supplier, and I found these guys. I have had nothing but an amazing experience with them. Cannot recommend them enough. So, set that aside. And along the SKR 1.4 theme we're going with right here, we have this guy, which is another thing I am very excited about, to be honest. Can't wait to upgrade the printer. I have no idea how hard it was to wait to open all this stuff so I could get a camera set up and I wasn't supposed to be working. Okay, so first off we have a small TFT screen to replace the LCD that comes with the Ender 3. I never really liked the graphical LCD that they used. Don't get me wrong, for a printer that's, I think, selling for like $249 US right now, it's perfectly fine and it works quite well. I just wanted something better. This also has a full-size SD card slot on the side of it, which I'm hoping I can use for sending prints over to it. Yeah, it'll definitely be an upgrade from where I've been before, and this should plug natively into the SKR 1.4 and give me a much better interface than what I am used to. There we go. Very first thing I'm printing on the new, once the new board is set up, is an actual enclosure and a mount for this to mount to the 4040 aluminum extrusion that the Ender 3 is made with. Alright, so after that, and along the same lines and in the same vein of progress, I actually have 4 of these, sorry. And these are the TMC 2208 stepper motor drivers. As I was talking about before when we were looking at the A4988 stepper motor drivers, this is the silent version. Now, the reviews that I have seen on these guys basically say that at the end of the day, when you're running your Creality Enduro 3 with these stepper motor drivers, the loudest thing about the printer should be the fans. I don't know if that's true. So we're going to go ahead and, as I said, there'll be a video of me building out the upgrades to the Enduro 3. And we will see if the hype around these stepper motor drivers are worth it. I also ordered this brass brush, which is designed to be a replacement for a different type of 3D printer. My intention with this is to print a mount, again for the 2020 or 4040 aluminum extrusion, so that the printer can use custom G-code to bring the print head over and rub the print head against this. I have found that over time the print head gets kind of gummed up and it's really hard to clean. So I thought this might be beneficial. If it is, probably what's going to wind up happening is another post-processing program for G-code for me, where at the end of every layer it goes ahead and wipes off the nozzle. I don't know why I'm such a fan of doing all of this stuff rather than, you know, writing Python plugins for Cura itself, but yeah, the DOS executables tend to be the way that I'm going. Simple brass, I'm gonna say brush, right? To wipe the nozzle off as you go by, and it should take the extra filament and extra plastic off the outside of the nozzle. I've been having a lot of problems with nozzle clog, and I believe the two reasons for that are the extra filament that's building up on the outside of the nozzle and the design of the Creality normal hot end, where the PTFE tube goes straight down to the top of the nozzle. And if they are not 100% just snugged right up to each other, then yeah, you're gonna have problems, and I'm pretty sure that's where a lot of my problems are coming from. Alright, so speaking of the hot end, I couldn't do all of this with my 3D printer and leave the hot end the stock hot end. I really don't like the design of the Bowden tube going all the way down there. Does it work? Sure. Do I get prints that are decent? Sure. But it's not as good as it could be. So I picked up one of these Micro Swiss all metal hot ends, again from 3D Printing Canada. Alright, now let's take a look and see what we get in the package. Alright, now this means that if we look at the picture here, the Bowden tube is only going to go to about here, staying well away from the hot area of the hot end, which should mean that there's less chance of filament building up in the middle there. Now, I've watched a lot of videos on this, and the assembly order that you assemble this in, especially mentioned in the Micro Swiss videos for assembling this, is very important. So we will be taking some time during our upgrade process to discuss how to build this out, because it's not a just throw it together thing. You have to put the parts on in a specific order, or you're going to have a lot of clogging and you're going to have a bad day. But if you do it the way that Micro Swiss recommends, apparently, I don't know, we'll find out, you won't have clogging issues, and this becomes a beautiful hot end, especially for exotic filaments and some higher temperature filaments, such as TPU. And in here, we get the cooling block, a link to step-by-step instructions that I'm guessing some people who've done reviews have not followed. Right, we've got the heating block, right, with the screw to retain the thermistor. Then we have the nozzle, which is a plated nozzle. It's not like a pure stainless steel nozzle. It's a plated nozzle. It should be resistant to some abrasion, a little better than a pure copper nozzle. But again, we'll find out, because I've been going through nozzles like they're going out of style. Mind you, I'm using the cheapest nozzles possible right now, so I don't think that that's too big of an issue. And then we got a bunch of hardware for mounting it, and the silicone sock. All right, we're just kind of powering through this, guys. Next, again from 3D Printing Canada, we have some premium PLA. Now this PLA, apparently the formulation of it makes it impact resistant and a little more tolerant of high temperatures. So what I wanted to do was take a look and test these claims with this. It is normal PLA, so it does print at the normal temperatures, but I want to see if it being exposed to a hotter environment, if it maintains its form and doesn't go soft as quickly. Because there's a few applications for things that I want to print with something that will deal with heat a little more. Your average PLA can start to get soft around 60 to 80 degree ambient temperature on the print, and that can be an issue for some things. So this is not a cheap filament, again from 3D Printing Canada, but it's something I wanted to check out. It is a filament that is made in Spain, again PLA, so any printer should be able to print with it. We're gonna have to dive in and see what this is like. And the last package that I have to show you guys is right here. This is one of the reasons I drove all those 3D printing parts. This is SainSmart 3D Printing TPU. This is a flexible filament. Right? I wanted to create more interfaces and buttons that felt a little better to the touch. Regular PLA produces a button that's very, I don't know, very 1980s original NES feel to it. Whereas this stuff I'm hoping will have more of like a Super Nintendo feel to it. And I do have a bag with desiccant ready for this to go into. So let's actually take a look at the filament. It is a really shiny blue filament. Holy crap, that's shiny. I don't know if you guys can see that on camera, but that has one massive shine to it. Again, this was purchased from 3D Printing Canada. Oh, that's not Ninja flexible, but wow, it's not very stretchy. But yeah, I think this will work well for interface buttons. We have, if you follow me on Twitter, you already know. If you follow me on Facebook, you probably already know. Right, but we have a new friend in the lab. Right, if you've been with us for a while, you know that I have been dealing with one of these tiny open source oscilloscopes, the DSO-138, right, as well as an 8-channel USB oscilloscope that is way too slow for anything I wanted to do. So, the time came and I had a little extra money and I went looking to find out what I wanted to buy. After bouncing around with decisions about 6 or 7 times, I settled on this guy, which is the Siglant SDS1202XE 200 megahertz deep memory scope. This is one of those tools that I am sure, while you don't immediately think of every way you're going to use it, it is going to affect every project we do in the lab. It is going to give me the ability to show you my scope screen in much more detail. The first actual electronics video after this one, it will be used in, and it's going to be invaluable for that. So that was purchased from Amazon. Shipping was a nightmare. It eventually did arrive. Well, 2 of them actually eventually did arrive. Anyway, we have it. It's a beautiful tool. I will actually be doing a review on this, despite the fact that there's probably hundreds of them out there. Everybody else that's done a review tends to be a professional electronics engineer, and I thought a review from a hobbyist might be valuable. So if you made it this far, thank you for joining me for the first of hopefully many mailbag videos that we end up doing. Yeah, if you like this video, thumbs up down below. If you're up for more content like this, or more electronics projects, or more DIY, hit that subscribe button with the bell notification to make sure that you get updated every time I put something new out. I do want to thank you for joining me in the lab. I hope you learned something today, even if it wasn't from me, and we will speak again soon.